Okay, so I have here a button, and connected to one side of the button is the LED. So this is one leg of the LED on this side of the button, and the other leg of the LED is connected to ground. So this is 5 volts. I'll connect 5 volts to the other side of the button. So let's check. So you have 5 volts on this side of the button, and on the other side of the button is the LED, and the other leg of the LED is connected to ground. I'll plug it in. So this button will serve as a physical switch, which will allow 5 volts to flow to the other side whenever it is pressed. 5 volts to the side. On the other side is the LED, and other leg of the LED is connected to ground. So pressing the button will close the circuit, allowing 5 volts flow to the other side. So this button is currently a physical switch. So let's create a logical switch this time. I'll move the button here. I'll connect this LED to pin A1 or digital pin number 15. Connect the button to a pin, and I will use that pin to determine whether the button is pressed or not. So I'll connect one side of the button. I'll connect it to pin number 7. So this is 12, 11, 10, 9, 8, 7. All right. So let's check. This button is connected to pin number 7. This LED is connected to pin number 15 or A1. So what we will do is we'll make use of the button as a trigger or a sign if we will switch on the LED or not. Whenever the button is pressed, we like to program in such a way that it will switch on the LED. So again, pressing the button will not switch on the LED, but we will write a program that will make use of the button as a way to find out or as a trigger to switch on the LED. First things first, the LED is connected to pin A1. Okay, so constant variable, integer variable, and name it as LED will be equal to 15, which refers to pin A1, or also known as digital pin number 15. Then I'm going to create a variable, a constant variable to store our pin number for the button. So this is currently connected to pin number 7, so I'll put 7 there. And then I'll set up the pin mode. First, I'll set up the LED. LED will be set as output because we'll send a signal out, which in effect will switch it on. So let us test. I'll send a signal out. So I'll send high or 1. It's the same thing. Program has sent a signal out to pin number A1 or pin number 15. That's why the LED is lit, because a signal is basically 5 volts. So if you send 5 volts, it is, or current is enough to light up an LED. So I'll switch it off. And then, so we are not going to set pin number 7 to input, to output, because we're not going to send a signal out. We are instead going to check the current status of the pin, whether it's high or low. So we're going to set it as input. Or is that correct? Let's find out. Because normally, if we are going to check for the feedback of a sensor, we normally set it to input. I wonder if that is the same case with a button. So I'll set the pin mode for button, which is pin number 7, to input. And before we proceed, let's check the status of the button by setting the serial communications on. Let's switch it on using this speed, and then I'm going to print the status of the button. So digital read. Okay, so let's check. See on the monitor. Upload, and let's check the result. Okay, so currently the feedback we're getting is 1 and 0, 1 and 0, which means we're really not sure if the value being reported by the pin, which is pin number 7, is 1 or 0. So sometimes it's 1, sometimes it's 0. So why is it like this? It's basically because pin number 7 is not connected to any circuit. So it's currently open, and it's actually absorbing electrical noise around its vicinity. So sometimes it's 0, sometimes it's 1, depending on the noise it's picking up. So again, what we are seeing here is the noise being picked up by the pin, which is open or floating. It's called floating because it's not connected to any circuit. Compared to a sensor, such as the line tracker, the signal pin is always connected to a circuit, and it's set as input. However, this one for the button is currently open, and it's currently floating, and is picking up any electrical noise. That's why we're getting zeros and one. So how are we going to solve this? When using buttons in Arduino, instead of setting it as input, you have to set the pin mode to input pull-up. Setting it to input pull-up will enable the pull-up resistor, setting the pin to high at all times. So let's do this. But instead, the button is declared, or the pin mode of the button is input pull-up. In this way, it will always be high or 1. And we are going to connect one side of the button to ground. So what will happen? Pressing the button will connect the pin, which is currently high, to ground. And when that happens, the status of the pin will change from 1 or high to low or 0. And that is how we will check whether or not the button is pressed. Again, pin mode for the button is input pull-up. It will always be high. And pressing the button, since the other side is connected to ground, will change the status from 1 to 0 or high to low. Let's add an if statement. So if, so we'll put the condition there. So making sure the brackets are correctly in place. They are okay. So what I want to do is I want to switch on the LED digital, right? LED to high or 1. So you can put 1 or just put high, whichever. It's the same. Otherwise, I will set it to low. The condition would be if the reading of the button will be low. If it will be low, because it's always high, it will mean that the button is pressed. So if the button is pressed, then switch it on. If the button is not low, it's high, then set it to low. Let's upload. In. Pressing the button will connect this side to the other side. setting it to low, from high to low, since our pin number 7 or the button pin is set as input pull-up. So basically, it's the same as connecting this pin or this wire to the other wire.